to go through because there's a lot of awesome stuff. Something near and dear to my heart, the space shuttle, the last existing external tank, the big orange one, got shipped out to Los Angeles, put on a flatbed truck, and driven down friggin' LA streets, like Culver City, Compton, like some sketchy ass areas. It now lives at the California Science Center and Exposition Park when it'll be mated to the Endeavour space shuttle that's been there. So yeah, there's a lot of cool pictures online from about 3-4 weeks ago when they did this. Very impressive through the streets of LA.
This one got some traction on the internet for a few days. Physics Outsider says NASA asteroid scientists are all wrong. Is he right? Anytime you see that headline, pretty much you can say no. So I mean, this guy wasn't a complete nut job. He was worked at Microsoft, had a PhD in physics, did some of his own research, and claimed that a team of scientists at JPL and Caltech had made serious errors when they were measuring the properties of asteroids. He was a little bit aggressive, told them they made colossal errors, even accused them of fraud, which is a huge deal in science. You don't say that lightly. It turns out, though, that he had made some incorrect assumptions, errors in calculations. Scientists at JPL did come back and confirm their own findings. Other independent groups have also confirmed their findings and said that this guy was wrong. I won't name a name because people shouldn't do this. This headline is courtesy of Phil Plait, of course, who wrote a great piece about this.
So this was on the International Space Station just a couple of weeks ago. The Bigelow Expandable Activity Module, or BEAM, one of the good astronomy acronyms, produced by Bigelow Aerospace out in Vegas. This is an expandable module that you can like put a bunch of them together. People can work inside of them, and this is sort of testing new technology for moon bases or Martian bases. So they attached one for the space station, they inflated it on the space station for the first time. It was astronaut Jeff Williams spent 7 hours expanding this inflatable habitat to a size of 13 feet by 10.5 feet. We are told by NASA he'll recover from like blowing into the tube. AstroBit wrote that joke. I'll give him props for that. So yeah, so very cool learning about these inflatable things that are pretty compact. You can expand them and live in them in space. Very nice.
So this is evidence that came up recently that there may have been gigantic tsunamis on Mars. This is really cool. So we're talking like 3.5 billion years ago. So when the solar system was pretty young, maybe 1 billion years old. A lot of people think that there were oceans on Mars in the early days, and one of the big problems with this is if there were oceans, you should expect to see shorelines. You don't see shorelines, so a lot of people are saying this means no oceans. Well, this team here, which included J. Alexis Rodriguez of the Planetary Science Institute in Tucson, Arizona, discovered that there may have been these tsunamis caused by meteorites that impacted Mars. So this was when the solar system was young, a lot of these things flying around. Impacted Mars caused these gigantic tsunamis. These would have been up to 400 feet high and traveled hundreds of miles inland. Just to give you a comparison, the 2004 tsunami in the Indian Ocean was traveled 1.6 miles inland and was 65 feet high, so many, many times higher than that. The cool thing about this is if there were a lot of these tsunamis, they will have erased the evidence of the shoreline. That would have been like gradually wiped away, which would also explain why we don't see that. So this is a pretty cool result. Not everyone agrees that there were oceans on Mars as recently as 3 billion years ago, though, so this is still an open area of inquiry.
So this lovely picture is one of the very few direct images of a planet around another star. So we have a star in the center, and then this little reddish fuzzball is a planet around that star, and astronomers have only done this a handful of times. So this star is about 1,200 light years away. This image was taken with a very large telescope down in Chile, and the planet is about 5 times the mass of Jupiter, which is a little bigger than our stuff in our solar system, planet-wise, but not outrageously big. But what's crazy is that it is 660 times further away from its host star than we are from the sun, so it's way the hell out there. 1 year on this planet is about 27,000 Earth years. So it's way the heck out there, but that means it's far enough away from the bright star that we can actually take a picture of it with some of the biggest telescopes on Earth. So very cool result, only been done a handful of times.
So you've probably heard a fair bit in the news recently about this possible planet 9. This is a planet further out than Neptune that may exist. If it does exist, it would explain some of the funky orbits that are going on with other objects further out in the solar system than Neptune, what we call trans-Neptunian objects. So this has been suggested because of these other weird orbits that it would explain them. It's never actually been seen. However, a new theory from computer models by Alexander Mustil of Lund University in Sweden suggests that this planet 9, if it exists, may actually have been captured from another solar system. So it might be an imposter coming into our solar system from elsewhere. So this would have been another star that was in the same cluster as our sun when it was born, and a planet orbiting that other star got captured by the Earth, by the sun rather, and is way out there past Neptune. As I said, this has never actually been seen yet, so this is still waiting to be confirmed.
But a preview of coming attractions, we will have an AoTATX talk next month about that topic, Planet 9. On to our next story here. Using observations from our favorite McDonald Observatory, the 2.7 meter Harlan J. Smith telescope out there, astronomers have found a young massive planet. The leader of the team was the fellow in the bottom right, Chris Johns Kroll from Rice University, one of my professors who originally taught me astronomy in undergrad, so you know he's a stand-up guy. His collaborator, who ran another team out at Lowell Observatory, Lisa Prado, down to the left here, but also part of this team because it was at McDonald, a lot of UT friends of ours, including Jacob McLean, Greg Mace, and Dan Jaffe, all UT astronomers. So they found this really young, massive planet. It's only 2 million years old, which is super young for a planet. It weighs about 11 times the mass of Jupiter, so this is a pretty bulky, big-ass planet, and it's really young. But most of the theories say that a planet that big should take about 10 million years to form. So how did this big old planet form so quickly? Back to the drawing board. Yet again, observational astronomers have found a new planet around a star that theorists can't explain. So the planet theory formation people have a lot of work cut out for them.
So this is another thing you may have heard about on the news from the LIGO collaboration.
Everybody sing along.
Yeah, everyone knows what this is. This is the second ever discovery of gravitational waves. So this is coming from 2 black holes that merge together. The black holes, as they come together, they'll spiral around each other, eventually coalesce into one big black hole. And this causes ripples in space-time, which is what's being discovered here. We had a long segment about this in February, when the first gravitational wave signal was discovered. This is showing that was not a fluke. There's another one. This is from December 26, what I refer to as Boxing Day. And this is discovered simultaneously in 2 detectors at opposite ends of the country. It comes from these 2 merging black holes, a bit smaller than the pair that were discovered previously. They weigh a total of about 21 times the mass of the Sun. So as well as confirming that the first one wasn't a fluke, this confirms the existence of black holes that are of similar mass to our Sun. So this is pretty cool and like a brand new area of research, which is very exciting.
And none of you should be surprised by that, because if you were here at an Astronomy on Tap ATX in March, nullifier of noise, Dr. Dennis Ugolini told us that they had live in the can already. So that shouldn't be surprising. What might be surprising is a recent press release from the McDonald Observatory. Dr. Andrew Mann, a fellow postdoc of ours at UT, led a team, including many astronomers from UT, including Captain AO, who spoke at AoTATX 11, and Captain Planet, who is here in the back and spoke at AoTATX 8. So lots of Astronomy on Tap friends on this project. So what the hell did they do? Why do we care? What they did was they found something that is a planet around a star that is not the Sun, about 5 times the mass of the Earth, what we call a super Neptune. So here is the system. It is a pretty beefy planet, bigger than the Earth, but not quite as big as Jupiter, about 5 times the size of the Earth. It is pretty close to its star, right? You plop it in the solar system, it's way smaller than the orbit of Mercury, so it's very close to its host star. As we heard a little bit in our first talk tonight, it's not clear where these planets form. If they form far out, they move in. If they form close, what goes on. But this thing is young, this thing is big, so clearly at least some pretty big planets form right near their star very quickly. So that gives us another piece of this puzzle of where planets form, what kinds of planets form, how they move around their solar systems. Very cool stuff from UT and McDonald.
Now, those of you who are regulars will already know all about gravitational lensing and why it's the coolest thing in the world. The main reason it's the coolest thing in the world is it's what I do. So one thing I talked about in particular in my talk in November, and has come up again since, is this multiple image supernova, supernova Wtf Star, which is in this galaxy here. There's a zoom in here. This is a spiral galaxy that is so far away, we're seeing it more than half of the way back to the Big Bang. It takes that long for the light to reach us. I don't know why this is jumping. So this galaxy happens to lie behind a gigantic cluster of galaxies, which means that the image of the distant galaxy gets magnified. You also get multiple images and all kinds of weird funky things go on. So this supernova here had these 4 images, and then another one that appeared here a couple months later. So this galaxy is in the news again. So far, all we have about this is what we call an astronomer's telegram. So this is a notice sent out by astronomers, including Pat Kelly, who discovered supernova Wtf Star, saying, hey, something weird's going on here. If you have a telescope, please point at this object. And the reason he wants everyone to point at this object is that they think they discovered what's called a caustic crossing event. So I'm going to play this again. So on the right here, this is an animation that I showed in my talk in November of what would happen if you moved a galaxy behind a gigantic cluster. And you see there's a line it crosses over where suddenly it goes completely nuts. So there's all these multiple images and it's gigantic and bright. That's what happens when it crosses over the caustic, which is just this imaginary line where you get theoretically infinite magnification. So this is really fake. This galaxy would have to be moving at trillions of times the speed of light, which obviously they don't. They move a lot slower than that. But what's happening here is one star in this galaxy here looks as though it might be crossing over this caustic. And so this one star is now bright enough for us to measure, which is really, really cool. At the moment, it's thought to be magnified by maybe tens to hundreds of thousands of times. But there should be a 5 to 10 hour period where it's exactly on this line where it could be magnified by tens of millions of times, which is absolutely ridiculous. This 5 to 10 hour period was thought to be anywhere from June 7th to July 7th. We haven't heard anything else about it yet, so watch this space. This might be a really cool thing in the news soon.
I sent a few emails saying, hey, if you need some telescope time, I've got telescope time, because I want to be a part of that. But nothing yet, we'll see. So this was a cool article that I saw many people posting on Facebook. Some archaeologists were digging up some stuff from King Tut, and they found one of the daggers that was buried with King Tut, and they did some tests on it, and they knew it was made of iron, which, okay, daggers made of iron, that's not crazy, but actually in ancient Egypt it was pretty unique. That was a pretty rare element at the time. But current tests, just over the last, announced about a month ago, figured out that the iron that made up this dagger came from a meteorite, and there was a decently well-known meteorite that landed a handful of miles away from Thebes, the capital of Egypt at the time. And so this dagger was made from meteorite iron. They thought it was, such a cool event. They should make a dagger, they should give it to the king, the pharaoh, and bury it with him. So pretty awesome, astronomy, Egyptology, history. Maybe the next Indiana Jones will go find a meteorite dagger. It can't be worse than crystal skulls, right?
And we want to finish on something that is very near and dear to my heart. I've talked about this a lot because I think it's the coolest thing in the universe. This is Tab Star. It was also nicknamed by the team that works on it, Where's the Flux? So you may also have heard it referred to as the Wtf Star. This is a weird star that shows irregular dips in its light, which means there's a whole bunch of stuff orbiting it and occasionally blocking the light, but it doesn't look like planets. Planets would give you a very particular signature that we don't see here. It was originally suggested it might be a bunch of broken up comets, but then that was kind of ruled out. And one of the leading theories is it could be alien megastructures. I said leading, not likely, but it's still the best candidate we have for a star with these alien megastructures around it. So this is really exciting. In order to get more data on this, the team working on it need to have a long, constant monitoring program of this star. This is a thing that is extremely difficult to get on publicly funded telescopes because you just can't get that amount of time. So they need to go to private telescopes. If you go to a private telescope, you need to pay for it. And normally these things would be funded through sources like the National Science Foundation or NASA, but the acceptance rate for grants at the NSF is currently sitting at around 15%, and that's improved. In fact, 15 is higher even than it was. So when you have an acceptance rate that's that low, they tend to only approve very safe projects that are definitely going to get results, and this is definitely not one of those projects. So instead, this team turned to Kickstarter, and on June 17th, they were aiming to raise $100,000. They got to 107% of their goal, so they have actually managed to fund this project to buy telescope time, which is awesome. So depending on how you look at this is either a really cool, exciting new way to fund science, maybe you should look into this, Jeff, or possibly a scathing indictment of science funding in the US. So you can pick your interpretation. That is Astronomy in the News for AoTATX number 20.